So data binding and view binding. So view binding is a simpler version of data binding. So what does view binding do? So view binding is something you just enable in your Gradle configuration, your build.gradle of your app module. Not of your overall project, of your app module where you have this Android bit, can enable view binding. What it does, it basically gets rid of find view by ID. Rather, it creates a binding class that basically allows you to then use your views in a type safe manner by name rather than by code, by using the find view by ID, which can also return null, etc. This kind of does something similar as that the Android extensions for, or the Kotlin Android extensions do, where the Kotlin Android extensions also create these synthetic properties. There are some advantages of using this over the Android for the Kotlin plugin, etc. But view binding is a relatively new thing, but it's an interesting thing. But the main interesting thing here is the data binding, because data binding is kind of a more complex version. It's older as well, and it is really powerful if you want to use it correctly. So conceptually extends this view binding concept, but view binding bindings created with data binding are much smarter than view bindings. View bindings just tell you, here's a property, that's that view. Data binding actually gives you a binding where you can set a property, and then based on what property you set, the view gets updated. And not only that, you can have things automatically update if they are somehow data that can notify of change, something that's observable or has a listener attached, as we use in our assignment. So basically, what does data binding do? So it extends the layout language, the XML layout, and you can then declare data parameters. I will have some examples later. And in there you can specify values. And of course, Android Studio supports this properly, so you get code completion, all that stuff that you expect. So enabling it is very similar to view binding, except in this case we have data binding that we say it's enabled rather than view binding. So we've seen how we enabled it, now we see how we use it. So rather than having our layout as the start of our design, we actually have a layout tag then that is not an actual element as you'd normally have in these layout files. We'd have this layout tag, and we have a data tag, and in the data tag you can create variables. You can also create something like imports, by the way. And in that, using that variable, then you inside your layout you can do things like you see here, where we actually have an add and then user.firstname. So the text that is used for this text view will be taken from this user. If you update that property, if you set a different user, it will also update these text views to have a new first name and a new last name. What it will not be able to do is say, okay, this variable actually can change underwater. So you need to set it again rather than just say change the property on the user. It won't be able to actually observe that this changed unless you have something that can actually notify of that change. So that is the idea. So you can actually have your layouts take properties and you get values from that. And that makes your code in a way much cleaner, because in your code you don't need to think about, okay, how do I set this value? Okay, how do I do if this changes, etc. We have in our layout, we basically say, okay, this is what it needs to display. What you do want to take into account there is that you don't want to put lots of complex code into your assignment. What you want to do is to keep these things simple. Keep the layout clean, and if you need a complex property, you want to make it work that way. And binding, so IDE support, there is IDE support for binding expressions, but it is still somewhat limited. But in general, it can get cluttered. So if you need to do something special, one of the ways you can do that is something called binding adapters. And a binding adapter basically allows you to also set complex properties on a view. So you can create basically a fake view property. That fake view property can then be assigned a complex variable, and then what you do is you, in that binding adapter, you can say, okay, this will actually set this particular coded properties on our view. One thing to take into account is that it uses Java syntax, not Kotlin syntax, where it's different. It's not very different. So it has a ternary operator, so the question mark, then colon else, so where Kotlin uses if else expression, it uses the ternary operator instead. It also, rather than the Elvis operator for question mark colon, Kotlin uses this binding expressions uses question mark for the same purpose. So if the value is null, does that. It does not have question mark dot. Instead, if you call null on call a method on a null property, it will just return null always. So it basically always does what Kotlin does with the question mark dot. Just something to keep in mind. Again, if you keep this simple, then it doesn't really go and hit you too much. And yes, the syntax differences can be a bit annoying, but they're easy enough to deal with. So how do you use these bindings? And there's basically, this is kind of what you want to do. You create, first of all, a data class. So a data class has users, etc. So this is the type that we're talking about. In this case, we want to make sure it works correctly. So if we make first name and last name a val, we cannot change them. So if we have a new user with a new name, we are forced to set it again. That helps us with keeping stuff correct as well. And then when you're in your own create, what you can do is to actually create the binding. So the suggested way of doing this is just, instead of doing the regular set content view, you just use data binding util dot set content view. What that does, it is it basically sets the content view. So it does the regular set content view, but it also creates the binding. So now we have the binding. You might want to store the binding as an attribute in your class rather than a local property though. In this case, this is an example I got from the actual slide website. We just say binding user equals test user. That's all. Of course, bindings can get much more complicated. We can have data bindings for collections. So yes, Android also has something called a sparse array. It's slightly different from what I have as a sparse array. There, if you don't fill anything in, it has a 0 value. It doesn't exist. So but the idea of sparse is that not every value is bound, the same as sparse matrix in the assignment. Anyway, so you can have imports here, and that makes the types available in other parts of your data binding. Yes, it's not 100% pretty, but we can live with it. And then we have the different variables. So The smaller than does need to be escaped, unfortunately. Those are the rules of XML. Again, live with it. And so you can have different variables, and then in the rest of your layout, you can make use of those lists and keys, etc. So, and yes, they do some magic to say, okay, actually the get method gets translated into an index access, as Kotlin does as well, by the way. Only Java doesn't. So this is kind of how you can do those things. You can also actually use bindings to handle events. So you can set a listener, say an on-click. You can give it the name of a method, regular. That is the normal way. Data binding, you can use a method reference. So starting with the type name and then colon, colon, etc. to do this. So when you give a reference, that means that when the binding is created, it will set that reference, and that will be what will be called when the event happens. You can also create lambda handlers, so lambdas, so inline functions. If you have a lambda that calls a method, that is only done when you're actually using your code. Again, the main rule there is don't put complex logic in your UI. There's tools available for accessing resources. So inside your data binding, you can also say, okay, I want to have some conditions. Maybe I have a different background if it's a super chat, whether it's a regular chat. So you can say, okay, if chat is super chat, put gold background, otherwise put regular background. And those backgrounds are just resource reference. Data binding will make that all work as intended. Much cleaner than if you have to do all this specific stuff inside your activity or inside a fragment. There's also ways where you can pass a binding to or pass stuff to an included layout, etc. If you want to know all the details, there's a lot of documentation available on the website, as I linked it in some slides previously. Then observables. There's a number of observable int, observable string, observable parcelable, observable many other things, classes. Basically, these are designed particularly for data binding, and these classes basically are wrappers for their underlying data type, and if you change the value, they will invoke a listener, and data binding knows about these types, so it will, if you set a property to an observable string, it says, okay, I know this is a special thing, so it will register itself to observe that object and update the actual set value. So it won't, and it will get the values out of the observable to actually use. However, these are a bit older. So this is before, so this was done already before the architecture components came into being. So there is also something called live data, which it also understands, which I would suggest you would use if possible. There's some other types that have a similar purpose that are automatically recognized by data binding.